Hello everyone, welcome back to my YouTube channel. So in this video I will be going to explain about embeddings, like where we can use it, what is an embedding, what are all the use cases of it, how it is used in the AI models. So let's get started. So basically embedding is numerical representation of any object that you can think of. It basically is used to capture the emotion or the details from the object with which we can identify it. So there are different ways to represent. One of the ways is by using numbers. So everything in the world can be represented in form of numbers, which can be interpreted by computers. So it is basically a way to represent meaning of a text as a list of numbers. And there are multiple use cases of embedding. So in the AI models, they are used to get the semantic search, clustering, classification. So I will be explaining everything in detail. So if you want to get the similarity between two objects, we can basically convert them into the numerical representation, that is embeddings, and then find the distance between that embeddings. So let's see dive into the use cases. So the first use case is for semantic search. So semantic search is basically the search that is in the meaning of the meaning or the context of the things. So imagine a library with a librarian who know the meaning of all the books. So instead of searching book by a name or the title or the author, you can just ask the librarian to give me this kind of book. So basically recommendation and document searching and semantic search are used. Basically works by getting the meaning of the content and then using it to search. And then the second use case is for clustering. So clustering is basically organizing stuff into categories. Think of vegetable, fruits, animals. They can be organized into categories. It basically identifies the pattern, like the one which I said, like if you want to get the distance between two, so if you want to get the similarity between two objects, we can just get the embedding, find the difference between them. If the difference is lower, that means they are similar. If the difference is higher, that means they are not similar. So in clustering, basically we identify the patterns and the structure within the data without any predefined categories. Example, customer segmentation. Then we go to the classification. Classification is basically a technique that assign data points to predefined categories. So let's say we have few products and that products belong to some categories, like there are clothing, there are electronics. So basically we have a classified types, like classified categories, and then we define the data into the categories. In clustering we don't have predefined categories. In classification we have predefined categories. So I was saying the calculating the distance between two numbers or two numerical representation or two embedding of different objects. This can be done using cosine similarity. So cosine similarity is a function where measure of similarity between two non-zero vectors. Here vectors is a array of numbers which is embedding. So cosine similarity is the cosine of the angle between the vectors, that is the dot product of the vectors divided by the product of their length or their magnitude. Let's see it with the help of an example. It will be much easier to understand. So cosine of two non-zero vector can be derived by using the Euclidean dot product. It is basically this formula: a dot b equal to a magnitude into b magnitude cos theta. So here cos theta is the similarity, like cosine similarity. Then if you want to find the cos theta, this is the formula: a dot b divided by the magnitude of a into magnitude of b. Magnitude is basically length of the vectors. Here basically dot denotes the product of the corresponding items from each vectors, and then we just sum them up. And magnitude is basically length of the vectors. So they are calculating using Euclidean norm, finding the square root of sum of squares of each element in the vector. And then cos theta is the cosine of the angle between two vectors a and b. So let's see an example. So let's say a is 1 and 2 and b is 3 and 4. Let's calculate their cosine similarity. So in the cosine similarity, basically we need to get the dot product, which is basically a dot b. We will multiply this with this and this with this, and then sum them up. So 1 into 3 plus 2 into 4, which gives us 11, and then magnitude of a is calculated as the square root of sum of squares of the elements, which is 1 square plus 2 square, which gives us 5, and then square root of it, which is root 5. And then same way magnitude of b, which is 3 square plus 4 square, which is 25, and the square root of 25 is 5. So now the cosine similarity comes out to be 0.786 approximately. So there is a homework for everyone watching the video. Please add your reply in the comment section. So there are two vectors. The first vector is having numbers 1 and 5. Second vector is having -2 and 1. So you need to calculate the cosine distance between these two vectors. Now cosine similarity can be between -1 to 1. where -1 to 0 means like they are completely opposite in the nature, and 0 to 1 they align to each other or they are similar to each other. So basically this is a diagrammatical representation of what I said. Like we have a text, the embedding would look something like this, which is basically a numerical representation of this text. And then basic use cases, like if we have these 5 boxes and all these represent the color that are inside them, so these and this will be somewhere similar, this will also be somewhat similar, and this will be similar. So this will be the representation, or like clustering will be in this format. These two will be clustered together, then this one, and then these two will be clustered together, and the distance between these two is less, then distance between these two is less, and then distance between orange one and the red one is less, and the distance between orange one and the blue one would be greater. So this is how embedding works. So we will be seeing this with the help of an example. So I have to see an example of embedding. I have prepared a code, sample code. Now I'm using the Cohere client. So basically Cohere is a model like OpenAI. We have Cohere for enterprises and all. It is basically very good for training our particular data, like training our data sets. So I have this Cohere token set inside the .env file. Let's try to, so let me first show you that it is working like ChatGPT, it can chat also. So the local server is running on 5174. I will hit and open up the console. So we got our response. So it basically gives us this. We ask me tell me a story in 5 part. It gives us this response. Move back to the code. Let me comment this out. So let me show you how a real embedding of a text look like. So this is the code to get the embeddings. So this is the model that we are using, and text is basically array of strings. What I will do, I will just comment this out and we'll see the embedding of this. I love to create cool stuff using coding. And then input type I'm using classification. So let me console log the chat, and I saved. Let's move to the browser. In the browser we got this response. In this we got our embedding, which is basically float or numerical representation of the text that we supplied to it, and the degree of the embedding is 1024, like 1024 arrays will be there. As you can see, like this is the embedding of that text. Let's move back to VS Code. So I have 4 statement. I love to create cool stuff using coding. Creating stuff using coding that are cool is my hobby. I have a bike that could reach 16 seconds. Apple is red. So you can see like these all are independent statements. This and this are quite similar, and then these two are not much similar. So here basically what I'm doing is I'm calculating the distance, like the similarity, the cosine similarity. This is a function which I have got from this library, compute cosine similarity. Basically it is performing the mathematical operation that I showed, and then it is comparing this with the consecutive string, and then this with this, and then similar way this with this. So let me save, move to the browser. So I got this similarity between this string and this string is 0.8, it's close to 1. So it means they both have similar meaning. And then the distance between I have a bike and then creating cool stuff is my hobby is 0.27. They are not opposite, but they are not much similar also. Then this is the apple is red and I have a bike. They have a distance between 0.11. So as you can see, by using this we can arrange different text, like we can basically classify different text, or with the help of embedding we can know the meaning of different text, how similar they are, how similar they are not. So a use case of it can be basically determining similarity between 2 images. That's it for the video, and I hope you like it. Please hit the like button. I'm very close to 30 subscribers. Please hit the subscribe button. Thank you.